Okay, cool. Well, hey everyone. I know you guys have been going through it today, talking to all different types of people about all things Flutter. Should have a pretty cool talk here today, mostly top level on how we built a macOS, Windows, and Windows and Linux application. I've obviously been talking all day as well. But that said, we're building a dev tool. We're going to get into some really interesting topics just on what it looks like to ship a production Flutter app to over 100,000 developers across these three platforms. We'll also talk about some pretty interesting technologies that are going on behind the scenes, notably on-device AI and hardware acceleration across each of these platforms, leveraging GPUs, CPUs, things like that. We'll talk about some tricks and tips we've done to optimize these AI systems. We'll talk about some database stuff. We've used almost every database in the Flutter ecosystem, so we can tell you pros and cons. And we're going to do some cool demos, right? How does all this stuff come together? How does it manifest into a product called Pieces for Developers? And we're trying to build developer tools for developers, right? And I think Flutter's a pretty special technology. We'll also talk a little bit about, I'll get into this in a sec, but we'll touch on web apps too. So we do a lot of plugins, and those plugins are actually web apps inside of Chrome, IntelliJ, VS Code, and their Flutter web apps. So we got some good stuff on deck. But anyways, thanks for bearing with me. Let's go ahead and get into it. So I'm Tsavo Knott, technical co-founder and CEO at Pieces. My passion definitely lies in writing code. I've been writing code for a long time, not necessarily doing pitch decks or spreadsheets or whatever else, but it's kind of the territory of the role. I will say, in a world that's very connected, the thing that kind of keeps me disconnected is going on nice camping trips way out in the wilderness with absolutely no Wi-Fi. So, that's a little fun fact. And I will say as well, the thing that makes me smile probably the most is like an all-test pass CI/CD pipeline. I don't know if anyone else can relate, but that just brings me so much joy because you're just like pushing and praying, and you're just like, hopefully it goes. Anyways. All right, so I talked about this a little bit quick. We did an introduction, but I want to do a quick poll across the audience. So who here kind of builds things with Flutter or Dart pretty regularly? I'm assuming a good amount of people. All right, fantastic. Kind of trickier question. Who here saves small developer materials like code snippets or screenshots or stack traces or things like that? You guys have processes for that? All right, less, but that's okay. Who here uses an AI tool in their IDE or in their browser or something like that? All right, great. We got some good adoption. Love to see it. And who here feels like they've achieved ultimate productivity as a developer? Okay, great. Absolutely no one. Fantastic. Us too, and that's why we're building some of this. So I chatted about what we're going to do. We're going to start out with what Pieces looks like today, and we're going to kind of work backwards on some of the things we had to overcome in the ecosystem. As I mentioned, databases, on-device AI, over-the-air updates, things like that. And then we're gonna kind of get into the details. So we'll do a semi-deep dive on FFI and on-device AI. Then we'll get into the part 2 of the demo, which is all things plugins and how we've gotten really creative modularizing components of our desktop app and actually embedding them into the IDEs on top of a thin data layer. So you'll see some nice, kind of deep IDE interactions, but still have a beautiful Flutter UI. And then, we're going to talk a little bit about where we're going tomorrow. Today, Pieces is a developer tool mostly for the individual. Given code is quite sensitive, we've been very cautious about our cloud architecture, how we serve it, some of the components around that, but really excited about that. And we'll mostly touch on the AOT, ahead-of-time compilation of Dart, and then serving it in a serverless environment like Cloud Run or Lambda functions or things like that. And then we'll finish with some questions. How's that sound? All right, cool, great. So we're just going to go ahead and, we already did the poll, fantastic. We're going to go ahead and show you what we're building. Now, as some context, pun intended, what we're building with Pieces is effectively long-term memory for developers, right? So you have 50 browser tabs open, you're like, what was that one documentation site with that one bit of code that I saw a couple days ago and I really need it now, right? Every time you're running into this because you're context switching, you're like, when was the last time I saw this error? You don't know, right? But how do we build systems that are secure, private, and real time that help augment this process for remembering things over the long term? So that's the macro vision. But of course, for something that kind of ambitious, if you will, you have to do it phase by phase. So I'll walk you through the phases. And you also have to do it vertical by vertical. So you'll see some technology today that applies to way more people than just developers, but we'll talk about why we started with developers uniquely. So product one, vertical one is pieces for developers. And we started with a place to save everything. I'll do a bit of a demo here in a sec. But then we got into phase two. Based on the things you have saved, can you have a kind of a contextualized co-pilot conversations? Can you leverage cloud models from different providers? And can you leverage on-device models like Phi3, Gemma, or Llama models? And then the interesting thing about phase 1 and 2 is they're very complementary, right? Where in phase 1, you save things to pieces. In phase 2, you generate things to save. And we're like, okay, this is really interesting. But the problem is that there's still that human-in-the-loop component. You have to remember, oh, I'm going to need this later. I'm going to save it. Or I need to generate some stuff. I'm going to go ahead and do that. So phase 3 is really where the magic happens. And by the way, we're going to be doing this entire demo. I'll go ahead and turn the Wi-Fi off. We're going to do this whole demo offline so you can see the true power of native AI. But phase 3 is basically pieces now saving things that it identifies that are highly likely to be reused later on your behalf, and doing this proactively across the browser, the IDE, and the collaborative environments. And then we'll touch on phases 4 and 5 a little bit, but I want to start with the green dots, which are where we're at. So let's get into a demo, and then we're going to talk about how we build this thing. Fantastic. My favorite part, live demos. Okay, so I'm going to go ahead and pull up the desktop app, and I'm going to show you where we began in 2020, right? So as a developer for most of my career, I'm in documentation, I'm looking at open source packages, I'm kind of giving things a scan. I'm like, okay, that's some interesting code. We always joke that code is like an image for developers, it's like worth 1,000 words, and you can kind of remember what it looked like and a little bit about what it did, but there's a lot of value in code and stack traces. So this is literally what it looked like for a majority of my career. I copy this code snippet here, I open up my Notes app, I go ahead and paste that in, and that's all I get, right? It is a really crude experience. And there's a lot more stuff that I need to do. I need to title it and tag it and organize it and do all this stuff just so I can find it later. So we said, we have all these technologies, why can't we do this better? So I'll take that same bit of code, and I'll go into pieces here. And actually, before that, I will duplicate a different piece of code so we can see it in its glory. And I'll make this a little bit bigger here. So I'm going to grab that code from my Notes app here, and I'm going to copy it. I'm going to open up the desktop app, and I'm just going to paste it in. Right away, what you're seeing is we said, hey, that's not actually just plain text. It's actually code. That's on-device ML. It's not only code, but we know that it's Dart code, so we're classifying it as Dart. You can see we're pretty confident, 99% sure that it's Dart there. But the real magic happens behind the scenes where we deeply contextualize this material. So we're going to go ahead and generate tags. So right here's all the tags that were there. Of course, you can add your own. We're going to generate suggested searches. So when you're searching things, you get search autocomplete, things like that. We're going to generate annotations. We're going to associate people where we've seen similar code that person was related to. And we're also going to associate relevant links out to external documentation like the Safe Int ID package or the Flutter Future Builder package. And so that's all happening within 200 milliseconds as soon as I paste that bit of code. That's a tremendous amount of machine learning. And so over time, what happens is you build up this micro repository of boilerplate, bash scripts, code snippets, screenshots, whatever else, and you have this pieces drive, and it's deeply contextualized. So this is really where we started in 2022, is like on-device AI, kind of getting our bearings around that level of enrichment, and then manifesting it in this micro repository. The last thing I'll mention around saving things is that you want to find them quickly and reference them and reuse them later on. So there's nice offline facilities around search. So I can go in and say, I want to look at some asynchronous data fetching with futures. Right there are my search results. I've got all my metadata on the side. Let me go ahead and switch this to light mode. Maybe that's a little better. But yeah, that's kind of like a search facility, right? And again, these are on-device neural code search embeddings, or graphical embedding spaces, GINA embeddings, that we're using to do all this kind of processing. So you can come in and search with a snippet, natural language, whatever else. So that was really what 2022 was all about, right? Saving things to pieces, being able to search for them, and really understanding like the internals of the AI. And then we got into phase 2, those generative co-pilots that I was talking about. So of course, for all your materials, you might want to start a co-pilot chat, but for this use case, I'm going to go ahead and create a co-pilot chat from scratch. So I'll go to my co-pilot here. and I'll start a new chat. One thing to note is I obviously don't have Wi-Fi, so I'm not going to be using any of the OpenAI models or Anthropic models or anything like that. I'm going to be using our on-device models. So we've got Microsoft. For this demo, I'll be using the Llama 3 8 billion, and I'm running this on a MacBook Air. But I'll go ahead and just ask a pretty simple question here. I need some code for a Dart CLI that prints out my name as the input args, or from the input args. If I can type Control Z. There we go. Let me retry this real quick. I am on a staging build, I know, but we just want to have the latest and greatest for you guys. So if you see small little things, like, don't worry about it. And yeah, so we're generating some code. This is happening with a small language model, completely on device, hardware accelerated, on a MacBook Air right now. So it looks like we've got our Dart function. Looks like a pretty trivial CLI. We're using some stuff where we're using the args package. Tells me how to run it, tells me some dependencies, and so on. Now the beauty of this is, okay, this is a pretty particular thing. I want to save that to pieces. And now it's captured outside of the context of this whole Copilot chat. So this is where you get into that generate, iterate, and curate loop, where phase 1 is deeply complementary to phase 2. And then the last thing that I'll go ahead and mention is we're in phase 3, and now we're going to get into a quick demo on phase 3, but we're going to get into how we're doing this, right? But phase 3 is this idea that as a developer, I'm not thinking all the time I'm going to need this later, but pieces is. Every 200 milliseconds, it's triangulating patterns across your entire operating system, Mac OS, Linux, and Windows, and it's saying, there's a high probability you might need this later. But it can do this for a long-term kind of memory, but it can also do this in real time. So what I'll do for this example is I'll pull up this native semaphores package. I'll scroll down and I'll take a look at the API reference, right? So this is a package I wrote for cross-process coordination using mutexes and semaphores across Mac OS, Linux, and Windows. So here's the API reference. I'll look at some of the code, and I'll just go to pieces and say, what was the package I was just looking at? So I'll start a new chat, and I'll turn on this thing called live context. And as soon as I'm in live context, Pieces is now understanding historical awareness about what I've done and what I'm now doing in the moment. So I'll say, what was the package I was just researching in Chrome related to semaphores? And I'll just start with that. So yeah, it's going to take a small second because we are basically taking that data, we're vectorizing it, we're putting it into an on-device vector database called Quadrant, and then we're retrieving against that data using those same embeddings, and then we're packing it into the context of the small language model, and we're using it as a generative output. So right here, you can see it's a pretty straightforward answer, but I was researching the runtime native semaphores package. And so I could say, can you generate some example code for that package in Dart? I'll just say, I won't even specify in Dart. We're going to give it a go here. And yeah, I mean, it's the end result of this is basically like, when was the last time I saw this error? Or what was that one site that had this like little bit of database code from around Thanksgiving? Or what was the last thing I left off on when I was working on this project? That's kind of what we're talking about when it comes to long-term memory. So yeah, let's see. We're generating some code. That's looking like some pretty good code right there. We've got our identifier, our semaphores. We'll see if we run into an output limit for Llama. I know it can only generate 4K tokens on the output, but that's something to note. Either way, it's doing a pretty darn good job. Yeah, we probably don't have to wait on it, but we'll get into the tech. So that's kind of phases 1 through 3 from a demo capacity for our desktop app. We'll show you some of the plugins here in a bit, which are used for Flutter Web. So real quick call out, one of the challenges with on-device models is I said that kind of token output limit, it cut off there at 4,000 tokens, and that's just one of the constraints of small language models. We're working with the Microsoft Phi 3 teams to make sure, like, hey, these models can be putting out larger context, but also ingesting larger context. So yeah, let's get to the tech, right? It's pretty crazy. How do we build some of this? All right. So there's a lot of nuances and initial challenges, especially when you're building a Flutter app. And we started building this in 2022, which was pretty early to the scene on desktop applications. Most notably, we knew that we'd be dealing with developer materials, which are sensitive by nature, right? They might have SSH keys in them, API keys, private keys, whatever else. So we wanted everything to be on device. The other reason we wanted things to be on device is from a business model perspective. If you're having to leverage the cloud to process all this data, and you're basically taking half your margin and giving it to OpenAI, that's not a good business model, right? And so we have these beautiful machines, we have existing hardware, why can't we get clever and leverage that? And so that was another big thing in the long term is like privacy, security, and then the business model. The other thing about that is I come from the web world, and I will say this, I got really tired of waiting on Safari to ship web GPU support, and so I still don't think it's out. But we wanted to use AI in every aspect of our product. And so that was one of the reasons we said we can FFI with C++ runtimes, we can FFI with Rust runtimes, we can get that high performance, but we can also get that 80% Dart and Flutter layer, which makes our development a bit more isomorphic. And then the last thing is cross-platform, right? We talk about this at Fluttercon all the time. That was a big thing for us. Some other nuances as well. Installation, right? It was pretty crazy, but we wanted a system where it's like if you've used Discord, it's basically going to come over the air. It's going to kind of install the update behind the scene. It'll give you a nice little banner that says restart to update. That didn't exist back in 2022, especially for macOS, Windows, and Linux. And so that was another thing where we're like, hey, this is something that the ecosystem deeply needs. And we actually have a package that is quite robust for Sparkle that's been on the docket to fully open source this year, which is exciting. Shout out to Nathan if he ever watches this. This guy is an absolute beast. But yeah. And then the other kind of ecosystem challenges are like, there wasn't really a good code highlighter package out there, right? So we had to build that. That's actually open source to date, which is really nice. There's a kind of a bunch of design system limitations where you have densities, you want to go a little bit beyond material design, and so there's a lot of upfront work. And then there's a little bit of difference, or a lot of difference, between Dart and Flutter. One of the nuances for us was quickly realizing that Dart doesn't have method channels. It doesn't have a way to pack assets into your AOT, whereas Flutter does. And so those discrepancies, kind of made it a little bit of a challenge. Yeah, and then of course this is with everything, but dependency, HE double hockey sticks. I think that the hardest thing is pod spec files on Mac OS. I don't know if people run into that, but it was a challenge for us. So let's get into phase one, really big things that we overcame: on-device AI material enrichment, and let's talk a little bit about general best practices if you're trying to implement AI into your app. So we started out with some stuff, your classic TensorFlow Lite, you got your concurrent neural networks, you got your LSTMs. We try to, training these things in PyTorch, kind of, doing that, and deploying it in Onyx runtime. We kind of ran into, a couple of different troubles, right? There's like disconnects of building the model in one language and then shipping it in another. And that was some stuff that, again, in 2022 was like very, very early on for on-device ML. And so, we found these challenges around cleaning that data. It doesn't scale well for local deployment. A model can only do one task at a time, things like this. And it was really expensive to kind of retrain these things. And particularly, we're talking about a transformer model here. It's a T5 model that you can actually, kind of fine-tune to do a bunch of different things. But before, we had very separate models that did very separate tasks. So if you haven't heard about this already, the way to go is not necessarily large language models to do a very small task. It's not necessarily individual models to do a very small task. It is 100% kind of low-rank adaptation models, LoRa, where you can say, we have a core, and that core is pretty good at doing a general amount of things. But then you can train particular embedding layers and dynamically inject them at runtime to do each particular task. So how does this look in our app? When we looked at the metadata that it generated, the tags, the descriptions, the related searches, things like that, those are actually dynamic embedding layers getting attached to the model at runtime, executing each of those tasks. So if you're looking at adding ML into your product, I promise you this is the absolute best way to go. There's a lot of material out there now about it. And as well, feel free to hit us up. We're happy to share anything that we kind of learned there. But what we ended up with is a very high performant, multitask capable micro model that runs exactly on your device. Yeah, and then again, we had a 200 millisecond latency barrier. We're like, this ML needs to be able to execute 200 milliseconds after I paste some code, or 200 milliseconds after I enter in a search result. And so that was a big one. Training is much faster. If you wanted to get good at a particular task, all you have to do is train that new embedding add-on, that additional embedding layer, as opposed to retrain the entire model. And it can be used in conjunction with a bunch of different tasks. So that was pretty exciting for us. Yeah, and if there's questions, maybe just make a note and we'll chat more about it at the end. I'll try and leave time. So the second thing, FFI, really, really big appeal for Dart and Flutter applications. And there's amazing code built into the operating system across Mac OS, Linux, and Windows that doesn't necessarily need to be rewritten in Dart purely, right? And there's also great ecosystems out there in Rust or C++ that you want to leverage, right? So we'll talk about some of the things that we've discovered as being A+. So yeah, Flutter method channels, pretty interesting, but the challenge with that is you end up writing platform-specific languages for each task. So for example, this popover that we have in pieces, that's like a Flutter web app inside of a little bit of Swift code, and we had to write Swift for that. We also had to write C# on Windows, and then I think we had to write something on Linux. That, again, shout out to Nathan, he's our Linux guy. But we knew that was 3 languages, right? And it was also not very elegant. You have different IDEs that you have to write these languages in and everything like that. So we found that as a challenge. And now what we're seeing in the Dart community is a big adoption around direct FFI. And I'll show you some code of what that looks like. The challenge there with Dart and pure Dart solution is there's not really good asset management. They're working on it with @asset annotations, but for us, we ended up, and believe it or not, we ended up encoding the dynamic libraries in base64, putting it into the Dart file as a string, and then decoding it at runtime to unpack that dilib, which was not good. Base64 is brutal. So let me go ahead and show you some of this stuff, just so it's on your radar if you're working with FFI. So like this code highlighter package that we have, this is one that's interfacing with another language. It's using a plugin or a package called Flutter Rust Bridge, which basically statically analyzes your Rust code, and then it'll create kind of the Dart side equivalent where you can call those functions. For me, I don't really like writing other languages. I like to just keep it in one headspace as much as possible. So that's on the method channels. That's on the Flutter to Rust or Dart to Rust FFI side of things. What I found out is that there's a tremendous amount of work getting done on Dart specifically, where you don't have to worry about generating or writing Swift code or anything like that. If you know the API exists at the platform level, you can actually just directly bind to it. And so you can do some ABI specific kind of integer mapping for your unassigned ints and things like that. But the beauty of this is it's 2 lines to call a particular function. So let me zoom in here. Apologies. So, for example, this is on a Unix-based system where I'm trying to open a cross-process semaphore, and this is a native semaphore. So all I have to do is understand the function that I'm trying to call, the semopen function. It's been in Unix since 1997. And then I have to just give this nice little @native decorator on it, and that's it. It's pure Dart code. And then from the callable side, all I have to do, this is on the Unix semaphore, so in my will attempt open and then my open function, all I'm doing is just calling that. Let's see, we'll go back. Maybe? Yeah, no Wi-Fi. Okay, either way, you get the point. I'll show it on the Windows side real quick. Same deal here. So let me go ahead and show you the actual binding, which is this decorator, same as Unix. So you got that @native int, and it's called wait for single objects. This is how you open up a semaphore equivalent on Windows. And then on the Dart side, same deal here. We'll attempt to open, and then inside the open function, I believe. Yep, from address. There's a little bit of stuff in here. This might be the superclass actually on it. Okay, will attempt block process. And also, don't judge my code. It was like late nights, just trying to get this thing to work, if you will. either way, all you got to do is basically call this function over here on the Windows side, which is just wait for single object, right? And so it's just a really nice way where this all the FFI work that's going on Windows, if you're trying to call native functions like vision processing or compression or encryption, you don't have to write that code in Swift. You can literally just go to the documentation, understand the inputs and outputs, write this decorator, and call it. And there's no dynamic libraries involved here. So this is a really nice solution. But either way, happy to talk more about that. Just wanted to say big shout out to the Dart team. They're working on that @native annotation, and it's pretty amazing. The last things I'll kind of mention on the kind of FFI front, if you will, there's a lot of work being done. So the FFI gen package has been tremendously improved over the past 2 years. The Flutter Rust bridge package is amazing. So you can go over to crates.io, look for a crate. If it's pure Rust, odds are you can use it in your platform. The Windows package as well, Win32, tremendous updates, and Windows Foundation is actually a complete binding to the Windows operating system using those @native annotations. And then there's some other like peripheral packages that help with strong typing, help with your kind of like unsigned to int to Dart int, your type conversions, things like that. But I want to call those out. If you're getting into FFI, definitely check out those packages. Cool. Let's keep going. So I tried to show you some of this stuff, but again, happy to get deeper on it one-on-one after this. All right, last one thing here is databases. This is super important to talk about when you're trying to build an application that's mostly on device, but we also had some other goals for it. So one of the most important things when it comes to a database is it's multi-process compliant and it's ACID compliant, right? So it's atomic, it's controllable, right? I can't even remember what ACID stands for, but for me, in my mind, it's like 2 processes right to the database at the same time. You don't have race conditions. It's going to be stable. And this is really important for cross-process database access, reads and writes, and everything like that. But in our database, we also had another goal. So our entire database is basically unstructured data with many-to-many relationships. And we also needed these things to have embeddings, vector embeddings, right next to the object types, right? So we can look them up on embeddings, but we could also look them up on traditional like full text search, whatever else. And then once you find something, you want to quickly look up with an O of 1 access all the things that are related to it. So that many-to-many relationship was super important. And then we wanted it also to be as isomorphic as possible. So if it takes memory, compute, and storage on my device, that's all I need in the cloud, or should be, and I should be able to say, all right, this database can run here, or it can run in a cloud run, or something like that. We talk about cross-platform, and then the last one is like schema management. Migrations are always super challenging. Shout out to Mark out here. He's probably like written like, I don't know, hundreds of migrations. And that's just like always a big challenge, and DevX as well. So let's talk about the databases we've tried, and hopefully I'll save you and your teams a lot of pain. So we started with Drift, as it's known now, which was previously known as More, and this is a SQLite database. We got into it, but there was a ton of boilerplate involved. It wasn't particularly scaling how we wanted to, and it's very strict schemas. So relational databases are actually kind of hard to leverage when you're representing many-to-many relationships inside of a graphical kind of database structure, if you will. And if you have done that, please send notes. Like we'd love help because SQLite is super powerful. But from our perspective, we like non-relational databases. That's where we wanted to go. So we ended up moving over to Sembast, which is a NoSQL database. It was super easy to spin up. It relied on JSON. It was pretty simple how it was operating. We're like, okay, we understand it, so we think we can use it. And what you don't understand, you cannot fix, right? So we're like, all right, we're going to use it. At the end of the day, it was not meant to handle as much data as we were throwing at it, right? And a funny story, I actually thought about putting some analytics, an analytics chart in here, but on Windows, we had a release in like January or February where we were storing the database in the user documents, right? We're using path provider, and we're like, okay, great. This is the folder we're supposed to put things in. And Windows, with an update, started to basically have OneDrive upload files from the user documents folder into the cloud. And we're like, what's going on? So we hopped on with some users. We're like, oh my gosh, half your database files are in OneDrive in the cloud, and the other half are on your computer. So we just saw like 30,000 Windows users, just like absolutely non-starter. I think that week alone, it was like 700 to 800 support tickets. Like we were like, this is crazy. And so we ended up like 5 or 6 patch releases every 3 days, like trying to get this thing fixed. And yeah, that was the long story short with Sembast, because it was doing roll-ups, creating new files that are temp files, and triggering OneDrive. So, these are just like the things that you don't realize when you're building a native app that ships across all these platforms. It's like, again, you're not going to realize these power tips until you go through it the hard way. So, hopefully that doesn't happen to anyone here. And what we're scouting next. So ISAR is probably one of the best, models for what it was trying to do. It's ACID compliant. The core is written in Rust. It's multi-thread, multi-isolate safe, and it's highly scalable. Although, Simon, I don't think is very much like actively working on it. However, the community has taken that over, and they're doing some really good stuff. You see some other ones as well that we're looking at, like ObjectBox, pretty interesting. But the general trend in the Flutter database world is like, if it's not coming from the Dart team, it might have some type of life cycle that's like a little unknown, and that's certainly scary. So if you guys want to collaborate on the database stuff that we're going to be doing, shoot us a shout out. We'll solve that problem for all of us, which would be cool. Okay, so that's a little bit about the desktop app. We talked about some AI stuff. We talked about some database stuff. We talked about some FFI stuff. These are just like broad topics that you want to scout ahead of productionizing your app. Now, we started to grow our team. We went from 6 people to 12 people to 17 people to 24 people, and we're like, okay, technical debt, the classic challenge. How do we get as much code to be reusable, like Flutter and Dart code, server-side, ML, infrastructure, product, everything like that? And Mac, and we had this on a hunch, by the way. We're like, we're going to take out a part of our Flutter app, we're going to turn it into a web app, and we're just going to put it in an iframe. And we're going to call that the UI for our plugins. So this was conceptualized probably like a year and a half ago. And then Mac this year made it happen. So good work, Mac. And we'll show you literally what our plugins look like. So, excuse me. You probably get the point. We build everything in Flutter now. And you also get the point that Pieces has a bunch of valuable developer materials. So for us, we're like, we don't want to have to go and we don't want to have to build UIs for every single application. Like I don't want our team to have to have a Kotlin kind of division where they're building all things IntelliJ, and then 0% of that is recyclable to VS Code or Cursor or whatever else. So what you've got here is IntelliJ running with Pieces inside of it. And you've got some native functionality. For example, if I look at this file and I'm like, okay, I want to save some of this to Pieces, I just select it, I right-click, and I save to Pieces. Like, pretty simple. And on the reusable side, I've got my snippets over here, so I can take a look at this snippet. Okay, that's pretty cool. And say I want to reuse this boilerplate, drag it and drop it. I've got that in there, etc. And then we've got the Pieces Copilot, which is also really awesome. So this right here is your Flutter web app. And it's basically rendered inside of a WebView 2. Chromium instance inside of IntelliJ, and it's actually quite interoperable. This is the same module that we actually have inside of the desktop app. So the UI is going to look the same, everything's going to be very similar, and we just took it and we said, okay, we're going to basically shrink this thing down. Apologies, I got two Pieces instances here, staging and production, but hang on one sec. We just did this, right? All we did was make our desktop app responsive, take it, plug it into IntelliJ. And I'll show you, you've got your stuff where you can come in and you can say, all right, I generated some code here. I want to insert this a cursor, and there it is, full bidirectional communication with IntelliJ Pieces Copilot. So we found out Flutter turns out to be a pretty good way to recycle your UI, deploy it in different environments, the web, desktop app, whatever else. And as it turns out, you can actually have this modularity built into the architecture. I'll show you another quick example there. I mentioned this popover up top where you can kind of manage your stuff. You can turn on the workstream pattern engine. You can pause it. You can kind of take a look at your backups, whatever else. Of course, I don't have Wi-Fi right now, so backups is useless. But either way, yeah, this is a Flutter web app inside of a Swift kind of web view, if you will, and it's just rendering as a popover. So that's Flutter as well. And then, we have our Chrome extension. You guessed it, it's written in Flutter. So we found a way to very quickly move components of our UI around to all the tools we want to integrate. So if you go to pieces.app and you check out the plugin, like we have NeoVim, JupyterLab, Obsidian, IntelliJ, like all these different plugins, you're like, how does the Pieces team build all these? It's not like just sheer man hours. It's actually very clever architecture, right? And that's the power of Pieces, if you will. Okay, cool. We'll keep it going. So we talked about basically the modularization of our desktop app, right? How quickly can we take existing resources, existing man hours, and recycle them to create new products? Now, there's one kind of nuance here, and that is like ultra multi-platform. And I will say, I'm kind of terrified if we get into mobile. I think it's going to be like we're going to lose our minds. But at least for the desktop app, you're kind of breaking out all your I/O functionality. You're adding in like the web-specific stuff unique to the WASM renderer, deferred imports, things like that. And the DevX for web is getting better, but it's not particularly great, right? So if you're building a Chrome extension, it's basically change some stuff, refresh it, go to Chrome, uninstall or reload the package, and check if it works, right? And you're doing this on cycles over and over again. So not particularly ideal, but I do believe that there's some good work being done, and people are looking at how companies like Pieces are recycling this code, and I think that we're going to see some pretty amazing fluidity between desktop and web here soon. Excuse me, I've been talking all day, so I'll take some water. Cool. Let's talk about iframes. So iframes suck. I don't know if anyone's worked with iframes before, but so VS Code, for example, doesn't have access to like the Chromium, like the headless Chromium. JetBrains does, a lot of other tools do, Swift does, things like that. But VS Code particularly is like, here's an iframe, good luck with your web app, etc. There's an open bug that we filed on Flutter's repo right now, and this is like how annoying it gets. But if you focus an input in VS Code, right, in the Copilot, inside of an iframe, and then you click outside of the iframe back into VS Code, it doesn't understand that you're trying to leave the iframe, and so the focus will remain inside of that input. The way we fix that is we basically have a listener on the VS Code side and basically a listener on the plugin side that says, okay, is my click inside or outside the plugin? And if it's outside the plugin, I'm going to force the focus beyond this iframe. So it's just like small stuff like that you don't realize until you get into it, and you're like, okay, that's annoying, but it's going to be fixed, and the Flutter team knows about it. So super exciting. Another super exciting thing, which was, again, like a little bit, growing pains, if you will, but we're really excited about it, is like the WASM runtime, the Secret runtime in the web is tremendous. I mean, you're looking at really good frame rates, kind of smaller bundle sizes, a lot of interop between WebAssembly. Like our Rust highlighter actually works on the web as well. So tremendous stuff going on there, and I think like that's just a testament to the work that's being done on the web, particularly around making this thing feel like ultra smooth, ultra reliable, and ultra portable. We talked a little bit about organizing I/O code versus web code. There's a lot of really great content out there. Again, happy to share resources and kind of brainstorm on some of that. You saw the bidirectional kind of communication between the IDE and the actual plugin itself. One small thing is like routing, pretty interesting, but as it turns out, you can merge routers. So you can have a package that has its own router, its own kind of navigational stack and things like that. And that module, you can pass in a router object and kind of connect them. So our Copilot module has its own router, but when it's inside the desktop app, it adopts the desktop app's router. It's really, really clever stuff that, again, Mac figured out. Shout out to Mac. But that was one of those things where we were going in, we're like, we don't know if this is going to work. Yeah. And then the last thing that I'll talk about is like challenges around contextual theming. So let me pull this up in VS Code, or maybe not. I'll do this in JetBrains. But the visual density and the theming. So we want these Flutter apps to kind of blend in. And you'll note like we got some big buttons, some big inputs, and some big text, and the rest of IntelliJ is like kind of small. So we're doing a tremendous amount of work right now around kind of like intelligent density, intelligent themes, to where if you take this Flutter app and you drop it into an environment, it blends in a bit more. It doesn't feel like very different. But again, these are things that are nice to have, versus need to have. And I will say big buttons are like tremendously annoying. Mac knows, but we're fixing that. But at the end of the day, it's like, do you have the functionality? Does the Copilot work? Does it understand your context? All right, cool. And lastly, 2 slides here. So we're focused on Dart everywhere. And I will say this is really where a majority of my time lives, is like isomorphic Dart, right? So as a CEO, I work with Mark, our CTO, and we think about technical debt, because at the end of the day, technical debt results in dollars, right? It either takes longer to build something, or you have to manage more things over time, and it's more manpowers. So all I have to say is AOT modules are amazing, right? So we have this CI/CD pipeline that basically builds out these AOTs, and these AOTs communicate on device as separate processes, either through inter-process calls or gRPC, so they can talk to each other. But in the cloud, it's the same environment. You take this AOT that's running on the device and talking to other AOTs, other applications. You put it in a Cloud Run instance, and now you've got gRPC in the cloud with the same code base. So AOTs are super, super powerful. I think like the work that's being done from ServerPod and some of the others, thinking about isomorphic Dart that runs on the client and similarly runs in the cloud with minimal amount of modifications, is really, really exciting. So continue to keep a lookout for that. And again, happy to talk about any of this stuff, but this is an example where there's 8 AOTs, if I counted correctly. Yep. I know Mark just shipped like 9 more, so that's awesome. And they just go through CI/CD. They test on Mac OS, Apple Silica, Intel, Ubuntu, and Windows. All that's good. We take the output, which is the Ubuntu job, we Dockerize it, and we throw it up in the cloud. So that's really amazing where, again, we're building on every single platform, and oh, by the way, all that stuff is isomorphically available in the cloud. So yeah, really exciting stuff there. Last thing we're working on. So kind of bringing it back to product, bringing it back to where pieces is going. We talked about this idea of long-term memory, and I think this is something super important for developers. As our world gets a little more chaotic, as we become Swiss Army knives, jumping around languages, jumping around projects and frameworks and things like that, I think the volume of context we're interacting with is going to continue to grow, and our managers or investors or whatever, they're going to continue to expect us to write twice as much in half the time. They're like, you got AI tools, like why aren't you generating all these features yet? And so from our product perspective, phase 4 is really about, if phases 1 through 3 are saving things and generating things and capturing things for you, phase 4 is, what's your current context? And we're going to go out and proactively find all the materials related to it and serve it back to you. So if I'm looking at a Webpack config, those are the dark days, it's going to say, here's the snippet that you saved. Here's some related links that you visit often when you're on this website. Here's a Copilot chat that you had. Talk to Tsavo, he works on Webpack, and also reference these projects. And then when you switch your context, that feed will dynamically refresh, kind of like a Jarvis or a heads-up display for developers to say, here's a new context, here's your feed, it's repopulated, here's everything we think you need. So these are the kind of amazing experiences that are coming when you combine the power of native applications through a platform like Flutter with all the innovation that's going on in AI. And I think like the future looks pretty bright for developer tools and overall experiences. And I will be very excited to have a system that actually remembers things for me, because I cannot keep it straight. Yeah, and then the final thing there is basically, like I said, we're building it for individuals, but first half next year, everything that shows up in your feed, if a teammate of yours is looking at the same context, we're going to figure out how to properly, and from a permission perspective, surface things that helped you in your journey to their journey. So if you're looking at an error and you're like, okay, this is the error I just got, and Tsavo or Mark solved that error a couple months ago, here's the websites they visited, here's the code they worked on, the projects they referenced, everything like that, immediately surface to your feed. So it's kind of like picking up where someone else left off in real time without asking them for it, asking the Copilot or anything like that. So everything we're doing for the individual, we are thinking about doing this for teams and enterprises, but it's a very, very large challenge. A lot of data, a lot of privacy, security, and I think like if we get to that point, it's a really exciting world. Cool. I think that was the last slide. Yeah. So thank you for listening to the talk. Hopefully it wasn't too verbose, but that is my tendency. Feel free to connect with me on LinkedIn or Twitter. Happy to talk about anything engineering-wise. Check out the booth, Pieces booth today and tomorrow. I know we got a confetti cannon, which is really cool. and hopefully you guys enjoy your evenings. So thank you so much. Cool.